A couple days ago I came across a paper published last month, and it is still messing with my mind. I'll link it in the description so you can follow along. It's called Unexpected Stable Stoichiometries of Sodium Chlorides. This is a rare case where the average person and a person well-versed in chemistry may both need a good explanation. Stoichiometry refers to the ratios of elements and compounds. In this case, sodium chlorides is also interesting because we typically think there's only one sodium chloride, table salt, NaCl. In other words, the stoichiometry gives us a 1-to-1 mole ratio. This paper talks about other stoichiometries that were synthesized, such as NaCl3, Na3Cl, NaCl7, and Na3Cl2. This may make even an experienced chemist scratch his or her head. How does this work? You learn in general chemistry about ions and balancing charges, so how can these molecules possibly have a neutral charge? From my understanding of the paper, these compounds were made under high pressures, more than 20 gigapascals, and they're not stable at atmospheric pressure. I'll talk about two of the compounds, Na3Cl and NaCl3, since the paper delves most into them, and I'll share what I understand. You're welcome to follow along and share your thoughts in the comments. The anion of NaCl3 consists of 3 covalently bonded atoms of chlorine with a single negative charge between them. The center chlorine contains 5 electron pairs, forming an expanded octet. The central chlorine is nearly neutral, and the 2 outer chlorines bear most of the negative charge. This is reminiscent of other trihalide ions, such as I3-, Br3-, and CiCl-. However, the chlorine is not as likely as the other halogens to form an expanded octet, and this is unusual. The crystal structure of Na3Cl consists of alternating layers of sodium chloride, followed by a layer of metallic sodium. The sodium is insulated by the sodium chloride and remains stable. The structure is still fixed with 3 sodium atoms for every chlorine, so it is considered a compound rather than a mixture. Hope you found this interesting and it got you thinking, even a fraction as much as it did for me. This illustrates something important about science. We never know anything 100%, and we'll have to change our views when something like this comes along. We must adapt our models to explain it.